and optimizing neural networks using these libraries. Throughout the workshop, there'll be ample time for all of you to ask questions and participate, so that participants can actually help with any challenges that they encounter and explore the potential applications of the 1DNN and 1MKL in their work. Before we begin with the session, folks, I have a couple of announcements for everybody. In case you're participating in the hands-on workshop, you can use the OneAPI DevCloud access to create your account, and it's mandatory to register. We're also excited to announce that during our live workshops, we'll be holding a lucky draw for 10 participants who ask relevant questions with regards to the content presented during the workshop on the Intel DevMesh channel on Discord. Now, the lucky winners will receive Amazon vouchers worth rupees 500. And we believe that this is an excellent opportunity for all of you to engage with our speakers and other participants during the live workshop. By asking the relevant questions on the Discord link, which has already been shared in the chat window, you not only increase your chances of winning the prize, but also get to learn more about OneAPI Analytics Toolkit, its library, and how they can actually help you develop high-performance applications that run seamlessly. So don't miss out on this opportunity to win and learn. Guys, as I told you, that the Discord link will be on in the chat window. You can go ahead and you can sort all your queries on that platform. Moving ahead, now it's time for me to introduce you to our guest speaker for today, who is going to facilitate the session. Please welcome Vasudha, who is our guest speaker and is an AI software solutions engineer at Intel. Vasudha helps customers and partners to optimize their AI workload on Intel platforms using Intel AI software tools and OneAPI high-performance libraries. She's an AI enthusiast with research experience and a master's degree in information technology from IIT Allahabad. Folks, please note that this session is scheduled for 2 hours with around 90 minutes for the presentation and the remaining time for the Q&A. In case if you have any questions during our session, you can send them to us using the questions tab on the GoToWebinar control panel. And also don't forget the Discord link that will be shared. Now, without much ado, I will hand over the session to Vasudha to take it forward. Vasudha, over to you, please.
Thanks, Kriti. So, hi everyone, I am Vasudha. I'm a software solution engineer at Intel, and I work in SCTG group of Intel, which is a software and advanced technical group. So, first of all, I would like to thank all the participants here for joining with us and having the interest towards the Intel OneAPI Code Maven hackathon. So welcome to this hackathon. So this hackathon is a good opportunity for all the participants here who have joined so that they can explore the power of OneAPI toolkit, which is designed to simplify development across diverse architecture and accelerate application performance. So I encourage all the participants here to please collaborate with your fellow developers and learn and showcase your skills and come with innovative application by using the Intel OneAPI toolkit to solve the real world problems for social good. So moving next to the workshop, first of all, I would request all the participants here to please join our Discord channel here. So link has been already shared in the chat. So you can join the channel there. So our experts are live there. They will quickly answer your queries. So please feel free to post any queries regarding the hackathon or the workshop. Our experts will reach out to you. And secondly, please let us know your feedbacks through the survey forms that will be presented at the end of the session. So moving toward the workshop. So this is the second workshop of this hackathon. So this workshop is based on OneAPI libraries, which is Intel OneAPI Deep Neural Network Library and Intel OneMKL, which is a math kernel library. So this is the agenda for today's session. So first of all, we will see what is OneAPI and why do we need it, and we also see the Intel AI tools, and then quickly I will let you guys to the Intel Dev Cloud registration process. So I request everyone to please register for on Intel Dev Cloud, because the hands-on session will be done on Intel Dev Cloud only. So to get the most from this workshop, please create an account on the Intel Dev Cloud. The links has been already provided in the chat section. And coming to the agenda, so further we will deep dive into the 1DNN library, and we have a two hands-on session here. So we will learn the 1DNN programming model, and in the second demo, we will see by utilizing 1DNN optimization how we can increase the performance for popular frameworks. Mainly, we will show the TensorFlow framework here, and then we will see the we will explore the features of one mkl library. So it is a set of highly optimized and thriller mathematical function. So we will see like how by using this optimized library we can enhance the performance in our application. And then we will explore one of its function, which is a jam routine for metric multiplication on Intel Dev Cloud itself. And at the end, we will have a Q&A session. So I will like to take some of the queries that you guys have posted. So in between that, please post your queries in this platform or on the Discord channel. So in the Discord channel, there are pretty exciting prizes as well for the top active participants. So please join that channel and post your queries regarding the hackathon or the workshop. So let's start the today's session. So, starting with the programming challenges that today's developers are facing while working across the multiple architecture. So, as you know, like in today's growing era, there are diverse set of workloads. So, if you talk about the IoT or if you talk about the AI or edge computing, there are diverse set of workload, and all these workload require diverse set of architecture. So, and apart from this, they also have own libraries, tools, and programming models that makes it very challenging for us to reuse the code and be productive across all the architecture. So this is the Intel solution, which is one API. So one API is an open cross-architecture and programming model that frees developers to use a single code base across multiple architecture. So uh, if you see the software stack here, so it has the different compiler like SQL, DPC++ compiler, which is a implementation of the SQL standard, and then different libraries for a different domain, like for one DNL library, one MKL library, or these libraries are there. And on top of it, middleware and framework are there, which use this optimized libraries to enhance the performance. And then on top of that, the users or application can use this optimized middleware and framework that are using the optimized library under the hood from one API spec. So the one API is open spec, and this is the Intel implementation of one API. So as you can see, it has many components that include compilers, compatibility tools. So by using compatibility tool, you can migrate your CUDA code to SQL, and then it has support for different languages and libraries, and it also has the analysis and debugger tools like advanced version of vtune and Intel Advisor. So all these are already there in Intel One API tools. So let's see. We will discuss all these libraries and compiler in the further slides. So as I mentioned earlier, the Intel implementation of one API has many components like language analysis, debug tools, and libraries. And most of these components could be installed, and it can be used standalone. And Intel has also arranged these toolkit in for specific application domain. So all these tool components are packed and brought to you in toolkit for specific domain and uses. For example, example, this is the Intel OneAPI based toolkit. You can find here everything you need to get started. And apart from this, you can see here there are other domain specific toolkit like Intel OneAPI tools for high performance computing, Intel OneAPI tools for IoT, Intel OneAPI rendering toolkit, and if for the AI ML and workload, it has Intel AI Analytic Toolkit. So Intel AI Analytic Toolkit is powered by OneAPI based toolkit. So if you are using an Intel AI Analytic Toolkit, so it is already taking the advantage of optimized libraries that is included into the OneAPI based toolkit. And then we have the OpenVINO, which is high performance library for the inference and application from edge to cloud. So this is the Intel OneAPI based toolkit. So you can see the different compilers and different libraries here, and analysis and debugger tools. So you can use this library no matter what your architecture is, whether it is a CPU, a GPU, or other AI accelerator. You can use these libraries, compilers, and other set of tools. So in this session, we will only talk about the Intel Math Kernel Library and Intel 1DNN library. So links has been provided, so you can go and explore the toolkit at your end also for the other libraries and compilers and tools. And this is the Intel AI Analytic Toolkit. So as you can see, the toolkit has four different sections. One is the deep learning, then machine learning, data analytic, and Intel optimized Python. So as I was saying, that Intel AI Analytic Toolkit is powered by OneAPI based toolkit. So it is already using the optimized library under the hood from the base toolkit. For example, in the deep learning section, Intel is working with Google and Meta for the optimization of TensorFlow and PyTorch. And both these framework has one by default one DNN integration. So so we will talk about this one DNN library in the further slides, and we will see like how by using the one DNN optimization we can get a significant performance boost for these frameworks. And similarly, if you talk about the other libraries like Intel extension for scikit-learn and Intel optimized XGBoost, these all libraries also use the optimized libraries such as OneMKL from the OneAPI based toolkit. So uh, so if you are working on an application, so you don't need to use the libraries like 1DNN and 1MKL standalone. If you are using AI analytic toolkit, then you are already enjoying the benefits of the optimized library that is included in the Intel one API based toolkit. So so all these libraries and tools are already there on Intel Dev Cloud. So you don't need to download or install or configure anything. You can get started with these tools and libraries just by one click. Just clone the one API GitHub samples, GitHub repo, and you can get started with those samples with these tools and libraries. So in the further slides, I will quickly let you guys through the DevCloud registration process. And if you haven't created the account yet, please create the account for yourself, because the demo will be done on the Intel DevCloud only. Before that, I request Sukriti to display the first polling question for our today's workshop. So, Sukriti, can you display the polling question here?
Sure, Vasta. Here you go.
Yeah.
You've launched the ball. Guys, please go ahead and vote and let us know if you signed up for the Intel One API Dev Cloud. This would give us a better understanding of detailing out the workshop and what was this trying to actually explain about the whole hackathon and the One API integration. So I see only 40% people have voted so far. We'll be keeping this poll live for a minute or two. So please go ahead and cast your vote. We should know and have an understanding of your interest and queries also. So Vasudha, so far 43% of people have said yes and 56% say no. There's still, people are still voting. There's 63% of folks who've actually voted so far. Guys, please go ahead and vote and let us know. You just have to click on a yes or a no and let us know. It's a simple process that we need to put into force. Okay. So I see 72% people have voted so far. Vasudha, I'm going to go ahead and close the poll now. Okay.
Yeah, you can go ahead.
And yes, the results looks like that 47% say yes and 53% have voted for no so far.
Okay, no problem, Sukriti. I will quickly let the participants to the Intel Dev Cloud registration process. So, those participants who haven't registered on the Dev Cloud, they can register for it along with me. I will let you guys through the process. So the link has been already provided in the chat. So once you click on the link, it will let you guys to this page. So you just need to click on the enroll button, and when you click on the enroll, it will take you to this page where you have to include your email ID by which you want to get yourself registered. And then after putting the email ID, you just click on the create an account, and it will ask you for some details like the email id, your name, and password. You can set your password here, and once it has been submitted, or one single use code will be shared on your mail. You can use this code to verify your email id, and once the verification is done, you can log in on the Intel Dev Cloud, and it will let you guys to a page. You just need to scroll that page, and when you scroll that page, you will see this kind of option, connect with Jupyter Lab. So you just need to click on the launch Jupyter Lab, and you have to click on the launch server, and this is how the interface will look like when you log in on the Intel Dev Cloud. So let me quickly explain the user interface for you guys so that you can quickly get started once I will show the demo. So I'm sharing my screen. So I just lost the connection for the Dev Cloud. Session has been expired. Let me log in here again. So this is how the page will look like for you. I'm still trying to log in. So this is the welcome page that you can get. You can go through this welcome notebook. So it includes the command for submitting the job over the DevCloud, and you can check the status on DevCloud by qstat command. So all these details are already mentioned here. So you can go and read this notebook, and apart from this, you can click on this plus button, which will give you the option for different kernels, and from which you can create the Linux. You can also open the Linux terminal here to interact with the files and folder and submit the jobs. So for me, it's still loading. Let moves to the slides, and during the demo session, I will again explain the interface here so that you guys can get started with me. So this is how you can create the account on Intel Dev Cloud. I hope all the participants have created an account for themselves. So as I was saying, the links are all links has been already provided for the dev cloud, for the Discord channel, and also for the one API samples from GitHub repo. So I request all the participants here to please clone this GitHub repo in their dev cloud so that they can run the demos along with me. So I hope you guys have received one link for this workshop, which is a GitHub link. So in that link, I have shared all the instruction how you can clone this library, and also the instruction for running the demos that I will present today. So if you are not able to follow or lagging behind the time, then you can take reference from those instruction point also to run the demos. And let's move toward the our towards session. So now we will see one API deep neural network library, so which is one DNN. So in today you have noticed like there are different deep learning based models, like if you talk about the speech recognition or the computer vision and or the language processing model, and all are based on neural network only. So what is one DNN? So one DNN is a cross platform, meaning you can use the same function or primitive on totally different platform, and it is a performance library mainly for deep learning application, meaning it provides highly optimized implementation of deep learning building blocks. So this API can be used both on Intel CPU and GPU, and it has support for Linux as well as Windows, and it has already been included in the OneAPI based toolkit. So if you are using the OneAPI based toolkit, so you don't need to install it standalone. And these are the different optimized functions and primitives that are included in one API deep neural network library. So it is a great example for highly portable and cross-platform library. So this has the primitives that has implementation for different, very different architecture, like for GPU, CPU, and other AI accelerator, and by various different vendors like AMD or NVIDIA, and they are using very various ISA acceleration like AVX 512 in various different formats like bfloat 16 or integer. And you can see that is it implement rich operators including convolution, matrix multiplication, pooling, batch normalization. So one DNN does not provide end-to-end optimization, but if you are using it, so most of your operations will be from the one DNN that is highly optimized, and that can give you the performance boost. And coming to its basic, so it provides support for the compilers like Intel One API, DPC++ compiler, and C++ compiler, and it has support for Linux, Windows, Mac OS, and it has support for Intel CPUs like Intel Atom, Intel all CPUs like Intel Core, Intel Xeon, Xeon Scalable processor, and the GPU as well. So coming to the next, we will see Intel One API one DNN programming model. So we will see like how you if you are using one DNN library, so how you can use the different optimized primitive in your application and get the benefit for your application as a performance boost. So this is an outline of the one DNN programming model, and the key concepts includes like primitive, engine, streams, and memory objects. So the one DNN programming model consists in executing one or several primitive to process data in one or several memory objects, and the execution is performed on an engine in the context of a stream. So we will go through all these key concepts one by one, and we will see how we can create this concept in our application and we can use it. So this is how you can create a different key concept that I have explained earlier. So you can create an engine by using this command. So engine is an abstraction of a computational device. So it can be a CPU or a GPU. So you can mention here like what is your device here. So it will create an engine. And next, you need to create a memory object for the input and output. So memory object comprises of two steps. So one is the memory descriptor and another is the memory object itself. So memory descriptor will include information like data type or memory format and the size of the tensor. And memory objects handle the data itself. And coming to the next, primitive. So primitive is a actual function that encapsulate particular computation, such as forward convolution or s- forward or uh, implementing different activation function or pooling. Such kind of computation. So again, for primitive also, it comprises of two steps. First is the primitive descriptor, and second is the primitive itself. So for primitive descriptor, it will include all the information that is required for the algorithm. Like as you can see here, we have created for the ReLU activation function, and we have included the information like what kind of uh, algorithm it is, and what are the parameters that is required by this algorithm. And then this is the primitive itself, where we have passed the engine as well as the primitive descriptor. And next to it, it is the stream, which will encapsulate the execution context tied to a particular engine. So we will learn all this in a demo also, like how we can create and how user can transfer their data from their buffer to the one DNN buffer. All these things we will learn through a demo. And coming to the next, so these are the application that has enabled with one DNN, and they are already enjoying the one DNN optimization in their framework. So you can see the popular framework like TensorFlow, PyTorch, MATLAB. All these frameworks are already using the one DNN library under the hood. And so let's see the one of performance benefit for one of the framework, which is TensorFlow. So this is the performance benefit of Intel 1DNN optimization with TensorFlow 2.8. So this benchmark has been done on AWS EC2 instance, which is powered by a third generation Intel Xeon scalable processor. So you can see the two results here. The on the left side it is the throughput result, and on the right side it is the latency result. So this throughput measurement has been done with AWS instance with 24 physical CPU cores and 96 GB memory on single socket, and the latency measurement has been done with the AWS instance with 4 physical CPU cores and 8 GB memory on single socket. So if you see the results for the throughput, performance improvement up to 3x is possible. And for the latency, if you're using a 1DNN enabled TensorFlow, it will took latency from approx 42% to 80% of the time that unoptimized version will take. So this is how, by using the 1DNN optimization, you can get the performance benefit with the TensorFlow framework. Similarly, there are benchmark for the PyTorch also. So you can go to the 1DNN links that has been shared, and you can explore at your end different benchmarks that has been done with the 1DNN optimization. And now we will see the we will go through the demo here. So we have two demos here for 1DNN. So in first demo, we will understand the basic of the 1DNN programming model. And in the second DNN, we will see how by enabling 1DNN, we can get performance improvement with TensorFlow framework. So I'm sharing my screen for the dev cloud. So just bear me for a second. It is loading and signing in. Meanwhile, I hope you all guys have registered yourself on the Intel Dev Cloud and you are ready to go with me. Yeah, so I have been logged in. Yeah, so this is how, once you log in, this is how the page will look like. So you can click on this plus button and then you will see the different kernels here, and you also have the Linux terminal here, so you can open a Linux terminal and interact with the your files and folders here. uh, and then once if you suppose you create a one notebook here, so this is how you just need to wait for the kernel to get ready, and once it is ready you can write your code and run the cells through this button. So this is how you can work with the Intel Dev Cloud. So I hope you have already cloned the Intel One API sample. So I have provided the link for the this workshop today, this repo for this workshop today. So I have included all these steps here for running the notebooks, and I request everyone to clone this repo also. So clone this repo and the OneAPI GitHub sample repo. So you just need to copy the link here, and you just need to open a Linux terminal here, and you can just type git clone, and you can place the link here and it will clone it on your dev cloud. So I have already cloned it both the folder here, so I am not doing it, so please do it at your end. Cloning for OneAPI samples will take around 4 to 5 minutes, and for the workshop it won't take much time. And once you have cloned it, please open this folder, which is Intel One API Code Maven folder that you have cloned, and open this Python notebook and run all the cells. So why I'm requesting is because it will set up the environment for the next demo that I will present today. Present because the environment setup will take around 8 to 10 minutes. So I request everyone to please run this notebook so that the environment will be set up and you can run the demo with me. So once the environment will be set up, so you will see the extra kernel here, which is a stock TensorFlow at your dev cloud account. So I please run this notebook at your end. And coming back to the first demo, yeah, so coming back to the first demo, just open the OneAPI sample folder that you have cloned. And once you have opened this folder, go into the library section, and in library, so you can see there are samples for different libraries that is there in the Intel OneAPI. So go to the 1DNN folder and open this tutorial, and here you will see notebook, which is tutorial getting started. So open this notebook here. So I hope you guys are following the instructions. So if you miss anything, please refer to the link that I have shared. I have included all the instruction there so that you can run this library. So you can see the kernel is ready. Now I will execute the cells to compile and run the program. So in this through this notebook you will learn 1DNN different 1DNN configuration, and you will see how to compile a 1DNN sample. And we will also see the we will also go through the OneAPI's 1DNN sample to understand the basics of 1DNN programming model. So I'm starting it, and I'm just ignoring all the warnings. And So one DNN has four different configuration. So each configuration support a different compiler and a threaded library. So if you run this cell, it will show you the four different configuration here. So I will only run this first configuration, which is with the DPC++ compiler. So if you are interested, you can you can explore other configuration at your end. So I will run this the first one only. So once after that, you just need to click this cell. So it will create a lab folder here. And once the lab folder is created, now you can run this cell. So what will, so it will copy the 1DNN sample from the 1DNN installation path to the lab directory. And once it has been copied, so you can see the content from this sample as well. So I'm not running it right now. And then you need to copy the other files as well from the 1DN installation path, which is the different header files and the CMake file. So I'm running this cell, so you can try at your end also. And now we will build and run with OneAPI DPC++ compiler. So as I said, like it has four different configuration. I'm running with the DPC++ compiler. And now, so please note that when you see your cell, so there are some parameters against CMake. So please remove those parameters against CMake to successfully build this program and run it. So again, please note that please remove the parameters from CMake so that the program can be successfully built and get compiled. So I'm running this script. So you will see build.sh file will be created. You can check this. So you can open this file. So you can see, first of all, it will source the OneAPI environment. Then it will make a directory, uh, which is DPC++, and then you need to change the directory, and then CMake will build your sample. So after writing the build.sh, we are again writing a file that will run our sample. So I have write a file ran.sh. So when you open this, so you can see it has the instructions for running the sample, and again it is sourcing the OneAPI environment settings. So make sure that these two files will be created at your end. So this is how you can interact with the dev cloud and submit your job. So I will show you in the next slides like how you can submit and check the status for your code. So you can run this profiling. So this is being done because we need to replace this with the actual path for the OneAPI variable. So once you run this file, and again when you open this sub folder, so you, yeah, so you can see that the path has been replaced. So this cell is for replacing the 1 year environment settings path. And now I will submit the code on DevCloud. So there are different ways by which you can submit. So qsub is a command that you can use to submit the job on the DevCloud. So this cell, maybe this cell will be not in your notebook. So I'm just I'm just commenting this cell. So you can see this, you have this cell here. So before running this cell, please open this q file and remove the replace the clx with icx, uh, because sometime before, I when I was using this, so uh, the CLX machine were not available and the sample was not getting built. So I request everyone, if you are you can run this cell. If you are getting an any error, like the your job is submitted in queue for long period of time, then please replace the CLX with ICX, and then you are good to go. So I'm just submitting the job, both build.sh and run.sh on Intel Dev Cloud. So it will first build it and then it will compile it to get the result. So so uh, please do that at your end also. And since the program is running, meanwhile we can go into the sample and understand what is there in the sample. So I'm going in the lab file. So you remember, like, we have copied this sample from the 1DN installation path. So I'm opening this file. So this is what included in this sample. So first of all, to use this library, you need to include the header files. So as you can see, I have included the header file for the 1DNN library, and you can also include this debug header file for debugging and analysis. Once after including the header file, first of all, you need to create the engine and stream. You need to define, like, which device on which device your sample will be executed, or 1DNN sample will be executed. So first of all, we will create the engine. So this is how you can create an engine. You need here you have to place engine kind, whether it is a CPU or GPU, and this is the ID of that device. So this is how you can initialize an engine. So as I explained earlier, engine is an abstraction of a computational device. And after creating the engine, you need to initialize a stream as well. So stream encapsulates an execution context. So as you can see, while initializing the engine, initializing the stream, I am passing the engine as a parameter here. So in this way, you can create an engine and stream. Now we have the engine and we also have the stream. Now we need a memory object. So we will create memory objects for input and output. So please let me know if I am going fast or you guys are not able to follow me, so that I will stop for a minute, or will try to go slow so that you can follow. And you can
Vasudha,
also,
Vasudha Kavita here. I would suggest let's pause for maybe a couple of minutes because some people are still stuck on the Jupyter lab.
yeah, yeah, sure, Kavita.
Maybe we'll take some questions on Discord.
Uh, yeah.
Vasudha, one of the question they are most of them are asking is after cloning, which directory do they choose? Maybe do you want to address that?
Yeah, yeah, sure, sure. Yeah, after cloning, I hope my screen is visible to all. So after cloning, go into the Intel One API samples. So this is Intel One API sample. Yeah. So go into Intel One API sample and go under the library section. And in library section, you will find the folder for all the libraries. So you need to go into the 1DNN section, and in 1DNN section, you need to go into the tutorial section. And in tutorial section, we have different notebooks here. So I have just run the getting started notebook, and you can explore other notebooks at your end, which is the advanced feature of the 1DNN library. So I have opened this tutorial getting started notebook here, and I have till now I have run all these cells. So one point that I wanted to note you guys, please remove the parameters after CMake uh, to get your sample successfully built and compiled. So as you can see on my screen, I have removed the parameters after CMake. And once this cell will, when you will executed this cell, so it will create a build.sh file that you can see here. And similarly, you we have executed this cell for running the code. So you can see there are two files here, run.sh and build.sh. And other point that I wanted all you guys to note is that mm, if you submit this code, and if you are getting any error, like or the like your code is in queue for it for very long period of time, so you can replace CLX with the ICX in the queue folder. As you can see, there is a queue folder also. uh, so you just open this file and replace a CLX with ICX if your code is not getting executed or it is queued for a long period of time. And then you can run this cell. So what it will uh, submit both build.sh and run.sh on DevCloud to build the sample and compile the sample. And you can check the status also by using this command. So you can just add a cell here, and you can just type qstat. By this you can check the status of the samples that has status of the files that has been submitted on the DevCloud. So for me, the education has been completed, therefore it is not showing the IDs. But if you see the logs here, so this was the ID when I submitted the build.sh file, and this was the job ID when I submitted the run.sh file. So you can see the status under the S column. So you can see right now for the this Jupyter hub it is running. If it is queue, it means your job is in the queue. So this is how you can analyze and submit your job on the Intel Dev Cloud. So uh, maybe I can move to the sample so that you can uh, understand like what is there in the getting started sample. So as of till now, we have initialized an engine. So as I mentioned, that engine is an abstraction of a computational device. So that can be CPU or a GPU, and this is the ID of that device. And next we have initialized a stream here, and so stream encapsulate an execution context. So we are passing the engine as a parameter to the stream. So till now we have created the engine and stream. Now we will create a memory object for the input and output. So we need some data. So here we are creating a four-dimensional tensor. So please note we are using four-dimensional here and stand for batch size. Since we have one image only, so I am uh, putting one here. So we need to have 4D tensor here, because all CNN primitives in one DNN library assume that tensor have the batch dimension as well. Therefore, we are including the 4D tensor here. And now we are computing the physical stride for each dimension. And this is a function that will map a logical index to the physical offset. And this all these things are happening on the user buffer. We haven't transferred on the 1DNN memory yet. So we are creating the data on the user buffer. And now this is the image size. Now we will allocate the buffer for the image and initialize its value. So here we are initializing the image with some values. So till now we have created the engine, we have created the stream, and we have initialized the image with some value. And now we will create the memory object. So memory object comprises of two steps as I explained in the presentation. So one will be the memory descriptor and another will be the memory object itself that will hold the data itself. So first of all, we will create the memory descriptor here. So this is how you can create a memory descriptor here. So you can see I'm passing the dimension for the tensor, which dimension for the tensor, and then I'm passing the data type and the memory format that we will use. So this is the memory descriptor. And now we have to define the memory object itself. So there are other approaches as well to define the memory descriptor. It has already there in the code, so you can follow all these instructions and comment to understand it. So this is the another way by which you can define the memory descriptor, and it is just checking the whether both of them are same or not. And now once the memory descriptor has been defined, we need the memory object for input and output. So here, this is the memory object for the input. So I'm including the descriptor here as well as the engine that we have created initially. And we are writing to the 1DNN memory function. And we are also making a copy of that image so that it can be used for the as a output memory object. So this is how we have created the two memory object here. So until now we have the engine, we have the stream, and we also have the memory object. Now we will define our primitive here so that the computation can be performed. So here we are taking the ReLU. We will create a ReLU primitive, and similar like the memory descriptor, primitive also comprises of two steps. First, it will take a primitive descriptor and then the primitive itself. So in primitive descriptor, it will take the description of the actual algorithm that is being implemented, and if other parameters are required, then it will take all these information. So this is how this is how you can uh, write a primitive descriptor for the ReLU function. So you can see we have passed the engine here. We have passed the information like for about the algorithm like forward inference, and algorithm is element wise ReLU. And then we have included the memory object here, source and destination memory object here. And see, these are the descriptor, not memory object itself. These are the descriptor, and then other parameters that will be required. So this is how you can create a primitive descriptor. Now here we are defining the primitive itself, which is the really primitive in our case. So we have just passed the primitive descriptor here to the ReLU primitive. And so now we have everything. We have stream, we have the engine, we have memory object, and we also have the primitive. Now we will execute it. So this is how you can execute this. You need to type relu.execute, and you can pass the engine stream, and here you will pass the memory object, which is the source memory object and destination memory object, and these two are only the tag to let you know like what kind of tensor each memory object represent. So this is how you can execute it. And after execution, we will wait for the stream to complete the execution. And once the execution is completed, now we need to transfer the data from one DNN memory to the user's memory. So what will we do here? So here we are defining a ReLU image here, and now see we are reading from the one DNN memory to the user buffer. Read from DNL memory, and we have taken the image, and the this is the destination memory object. So this is how you can create all these key concept in your sample and transfer data. We can read and execute, and you can run this sample if you want to verify whether the results computed with the 1DN and primitive is correct or not. So you can uncheck this code and you can verify at your end. And if the sample is uh, successfully built and compiled, then you will get 10 output showing like example has been passed on the engine that you have mentioned. So we will go to our notebook and we will see here. So you can see we have get our sample has been successfully built. So you can see that if the build.sh is successfully built, so you will get this kind of output, like build files have been written to your this path, and build target getting started cp. So this kind of output you can expect. And once the run.sh will be completed, so you can see that example passed on cpu, this kind of output. So this is how you can compile 1DNN samples and run at your end. And moving, I hope you guys have able to follow. If you have any queries, please post it on the Discord channel. Our experts are there; they will answer your queries. So, so moving to the next sample. So which is this sample, in this sample, through this sample we will explain like how by enabling 1DNN optimization you can get the performance benefit for the TensorFlow framework. So as I requested before, please clone this repo from the GitHub link that has been shared with you, which is the Intel OneAPI code manual. So this is the link GitHub repo that I am talking about. So please just copy this link and open a Linux terminal here and clone it at your end. So once you open this folder, so you will see a notebook here which is for the environment setup. So as I requested earlier, please run all these cells so that environment can be set up for this demo. So it will take around 8 to 10 minutes, and once uh, the it has been completed, you will see uh, stock TensorFlow kernel in your uh, launcher. So I hope you guys have already run this notebook and you can see a similar kind of environment setting at your end. So this is nothing. We are just creating a environment, and we are installing this stock TensorFlow and adding the registering the kernel to the this Jupyter notebook, and we are submitting this. So it will create a setup environment.sh file, and I'm just submitting on the Intel Dev Cloud, as you can see. And you can check the Q status here from QStat. So because I have already done at my end and the environment is all set up. Therefore, I'm not running it again. Please do it at your end so that you can run the second demo along with me. So after finishing the environment setup here, again you need to go into the Intel One API samples. And so please, if you are getting confused about which directory you have to go for a particular demo, so please follow the instruction here. So for example, in the for the first demo I have mentioned the whole directory path where you can get that sample, and similarly for this sample also you can go into the OneAPI samples AI analytics and then follow this path only. You can get the sample. So and now go into the AI analytics section. So in the analytics section, there are three different folders like end-to-end workloads, feature and functionality, getting started sample. Go into the feature and functionality section. And in this section, open this folder, which is Intel TensorFlow Model Zoo Inference with FP32 int 8. And in this folder, open this ResNet 50 inference notebook. So I have opened this notebook and you can see that kernel is getting ready. So I'm selecting this stock TensorFlow kernel that I have set up with the Conda environment setup notebook. So similarly, you can select this kernel from, just click on it and you can select the kernel from the list down. So click on the stock TensorFlow and select it. And once it will be ready, we will execute. Yeah, so as you can see, the kernel is ready. Now we will execute the sample here. So right now, the 1DNN, so you can disable 1DNN by this environment setting. So you just need to set this value to 0, TensorFlow enable 1DNN optimization, which is set to 0 for disabling 1DNN. So first we will check the result by disabling the 1DNN, and then we will enable it and we will see the result. So 1DNN is disabled and the precision that we are selecting is FP32. And now we will download the Intel pre-trained ResNet 50 model from Model Zoo. So again, for me, since I have already downloaded it, so for you guys, it will take some time, around 2 or 3 minutes. It will take some time to download the ResNet 50 model. So I will wait for you guys to download the model and then we can get started. I hope you guys are able to create the environment and running this notebook along with me. And once the model you have downloaded the model, you can run the cells uh, to get the result. So I'm running it, and currently I'm running it for the batch size of 128. And so so we will get the throughput results. So if you want to have the latency results, so you can set the batch size to 1. So executing this cell will take some time, so it will take around 2 to 3 minutes to for completion. So you can wait here, and meanwhile I will create a text file to record the results. So we will record the result with 1DNN disable. So so this will take some time, and you will see the result here for the batch size of 128. So as I said earlier, so Intel has worked with Google to include all these optimization with the TensorFlow framework. So if you are using the TensorFlow uh, or PyTorch, then you can enable the 1DNN optimization by this method. And if you are using the AI analytic toolkit from Intel, then these are already integrated by default. So you, if you are using the AI analytic toolkit, so you will be already enjoying the benefits of 1DNN optimization and other libraries. So it is taking some time. I hope you guys are also running and able to run it along with me. So meanwhile, let me repeat these steps so that the participants who are not able to follow or lagging somewhere, they can start. So you just need to clone this samples from the GitHub page. Just copy the link here, and also the links has been provided in the chat. So you just use that link and open a terminal here from here. So you can just open a Linux terminal here and just clone this GitHub repo at your end. And after cloning it, you open this folder and open this Conda environment setup notebook, and run all these cells so that environment can be set up for running this demo. So, and once the setup will be finished, you will see a extra kernel here, which is the stock TensorFlow uh, envir- envir- um, environment settings. So we have the result for the 1DNN with 1DNN disabled. So this is the throughput that we got when 1DNN optimization is disabled uh, with TensorFlow. Now we will enable it and we will see the results. So I'm just replacing 0 with 1. So this is how you can enable the 1DNN optimization in TensorFlow. So I have just enabled it, and you just need also, please, for the safe side, restart the kernel so that it can be enabled. Yeah, so run this cell. Again, repeat, run all the cells in this notebook. And then we have the result for the 1DNN optimization. Yeah, so again, I have chosen the batch size 128. So if you want to check the result for latency, please modify the batch size to 1. So again, it will take some time for the results. So you can wait here for some time. So please feel free to post your queries or doubt regarding the hackathon or the workshop or anything related to the demo in our Discord channel and on this platform also. And again, I'm repeating, like, there are exciting prizes as well for the participants who will be top 10 participants who will be active on the uh, Discord channel. So there are Amazon vouchers worth rupees 500 for the active participants on the Discord channel. So yeah, it will take one more minute, and then we will have the throughput result with 1DNN enable. So please note that higher the throughput, better is the result, because it represents like how many images has been processed in that particular time. So you can see we have higher throughput now, which is 214.513 images per second as compared to the previous one. So this is how you can see that by enabling the 1DNN, you can get such kind of performance benefit. So this ends the demo for the 1DNN, and now we will go to the next section of our workshop today, which is the Intel 1MKL. So we will start the 1MKL section. So it is 1MKL math kernel library. So as you know, like almost in every domain, we are using math. So if you talk about the IoT or AI or other domains as well, everywhere we are using math. And if you are using the math, then you can use this in math kernel library. So you must have gone through all these mathematic function like dense linear algebra, sparse linear algebra, fast Fourier transform, and a vector random generator in your academic. So you would be already familiar with all this mathematic function. So what is 1MKL is? So 1MKL is basically a library of highly optimized, threaded, and extensively parallelized routines. So this has been built to provide you maximum performance across varieties of CPU and accelerator. So it has language support for SQL, Intel C, and Fortran compiler, and it is freely available. And you can use this Intel 1MKL library for different domain, as I've said. Like you can use it for the scientific, engineering, and financial application by using the highly optimized, threaded, and vectorized math functions. So in the next slides we will see some of the math functions that has been optimized in the Intel 1MKL. So these are the few these are the math functions that has been optimized under this library. So you can see under linear algebra we have different routines that has been implemented in the 1MKL. So BLAS, which stand for basic linear algebra sub program. So this routine provide vector, and matrix operation. And similarly, there is a routine for sparse BLAS. So which this routine will provide basic operation on sparse vector and matrices. And then there is a routine named as LAPAC. So this routine solve system of linear equation or eigenvalues and singular value problem. And then we have a direct and iterative sparse solver among several options for solving sparse linear system of equation. And then there are routines for the Fourier transform function, which is the FFT routine that has offers several computing from FFTs. And then there is a vector mathematic function that includes that will compute core mathematical function on a vector argument. And then there are vector statistic function as well that will generate the vectors of pseudo random numbers with different types of statistical distribution and perform convolution and correlation computation. And then there is a statistical function that provides a set of routines implementing commonly used pseudo random generator with continuous distribution. And then at the end we have this data fitting function, which provides spline based interpolation capabilities that you can use to approximate functions, function derivatives, or integrals and perform all such operation. And we have also this vector math functions that include trigonometric transform that you can use to compute sine, cosine, and staggered sine, cosine, such kind of computation. There are other as well, like hyperbolic, exponential, log, power, and root. So this is all the these are all the mathematical function that has been already implemented in the 1MQL in a highly optimized way. And the boxes that you are seeing here, like the red boxes and the dash red boxes. So red one, this represent the support for Intel processor graphics, and the dash one represent the partial support for Intel processor graphics Gen 9 and Gen 12. So now we will move towards the demo, where we'll understand one of its routine, which is a jam routine for for matrix multiplication. So again, I am going to the Intel Dev Cloud. So I'm closing all these previous files here. Yeah. So to get this sample, go into the OneAPI sample, and into the OneAPI sample, go into the library folder, and in this folder, go into the OneMQL section. And in OneMQL section, you can see there are different routine. There are samples for different routines that has been implemented in OneMQL. So we will be doing the matrix multiplication. So I'm opening this section. So this is how the directory look like. So you need to build the samples and compile it. So for that, I am using a Linux terminal here. So you can open the Linux terminal, and before that, please make sure that you have sourced the OneAPI environment. So just for your information, this is how you can uh, source the OneAPI environment. Because I have already done it, but I'm doing it for you guys. Mm, let me check. You can go in this folder and check for OneAPI. Yeah, there is a folder here, OneAPI, and you can go in this folder and you can see the .sh. So yeah, so since I have already sourced the environment settings here, so it is showing these kind of warnings for me. But for you guys, let me try with force. So you can see how sourcing one API environments look like. So so you can see this is how the one environment. So it will activate all the environment settings for one API environment. So yeah, so please make sure that this you have sourced the one API environment settings. Now we will move towards the one API samples. So you let me Yeah, so you can see the there is a folder for OneAPI samples. I'm going to that directory. You can uh, go along with me. And in OneAPI directory, we need to go into the libraries folder, and then you need to go to the OneMKL directory. Yeah, so now you are under the OneMKL, so you can see the different routines here. So we need to go for the matrix multiplication directory, and yeah, so now we are under the matrix multiplication directory. You just need to type make command, and it will compile the code for you. So since it is getting executed, let's go through the sample and understand how we can how we can use the routines from MKL library. So first of all, you need to include this header file for the one MKL library. And after including the header file, now this is how you can initialize the data for gem routine. So you need these parameters alpha and beta, as well as the a and b matrices. So here we are choosing the alpha as 1 and beta as 0, and this routine will calculate the matrix multiplication. So here we are taking the two row measure layout matrices, and now we will initialize the um, dimension. And we so here we are initializing the strides to get the elements of the matrices. And now, so this is the scaling factor alpha and beta that I have explained here. So we have initialized this as well, and now we are selecting the device here. So if you have attended our first workshop that was based on the sickle, you must be familiar with this command. So this is how you can create a queue uh, on the for the default device. Or if you want to create a queue for the CPU, then you can select CPU selector. If you want to do it for the GPU, then you can select GPU selector. And now we are allocating the memory for the matrices, like for A, B, and C. And um, and after that, we will initialize the matrix data here. So for matrix A, we are randomly initializing the data for matrix A and matrix B. And after that, we are launching here the uh, one MKL gem routine for the matrix multiplication. And for the reference, for the validation, we are also computing the multiplication here and storing it in a C reference. So we will compare these two results to check our accuracy. And we will by this command, we will wait for the one MKL computation to finish, and then we will free all the memories for the matrices A, B, and C references. Now, so this is the program where we will verify the computation done by the jam routine and the reference computation that we have done for the matrix multiplication. And if the results are good and correct, so you will get a similar kind of output, like results are accurate. So let's check our code here. So you can see that we have the output, like it has launched the one MKL GMM calculation, and it has performed the reference calculation as well. And it has verified that both the results are same and results are accurate. So uh, this is how you can make use of one MKL library. You just need to include the header file, and then you can um, you use the different math routines. So you can go into the one MKL link that we have already shared with on the hackathon problem statements also, and in the chat also. So just go through the that site, and you can learn for all other routines as well. And also, as I mentioned here, there are there are samples for other routine also, so you can explore it at your end also. And apart from this, um, by default, it has also one folder which is Intel One API MKL training. So you can run the samples from here as well. So it has the implementation for jam routine. So if you open this folder, so there will be three folders here. So let me open this folder here. So this notebook, one MKL intro notebook. So in this notebook, you can learn about the by different ways by which you can execute the code. So an mql, you can use the one mql with two settings. With one is the with dpc++ and other is the openmp offload. So again, with the dpc++, there are two types of memory management model that you can use. One is the buffer and ssr, and another is the unified shared memory. So therefore, when you go this matrix multiplication module, so you can see there is a sample with dpc++ with the buffer memory management model, and there is a dpc++ sample with unified share memory model, and there is a sample with openmp offload. So you can click anyone and you can try at your end. So this is a Jupyter notebook, and what I have explained is a C++ a file that you need to compile through your Linux terminal. So you can try in this by this way also. And this folder is by default, it's there in Intel Dev Cloud, Intel One API MKL training. So this ends the demo for the One MKL library. So moving toward our slides. So before that, let me summarize the workshop for today. So till now, we have seen the introduction to One API and see why One API is required, and we have seen the different libraries from One API based toolkit, and we have also explained the Intel AI Analytic Toolkit, and then I also let you guys to the for the DevCloud registration process, and then we deep dive into the one DNN library, where we have seen the hands-on session for one DNN programming model, and then we also see the one DNN enabling and disabling environment setting for the TensorFlow framework, and we have seen the result for the throughputs, and then we have explore the one MKL library and a different function under this library, and we have seen the demo for the matrix multiplication function with the one mkl. So the this is all that we have for the today's workshop. Now moving toward the hackathon part. So in this hackathon we have three problems statement. So you must have I'm hoping that you all have visited the site and are already working on the addition phase. So there are three problem here. So for the I will not focus on the second problem because this problem has been already covered in our first workshop. So moving to the problem one, which is the uh, predicting consumer sentiment problem. So as you know, like today, businesses and various e-commerce website, they use the consumer sentiment to improve their marketing strategy and improve their sales. So by understanding consumer sentiment, they can tailor their messaging and advertising to appeal to their target audience. So your task is to build a predictive model that can analyze social media activity to determine consumer sentiment to a particular brand or product. So the data set for this problem statement has been shared. So please go to the hackathon website. You can get the more details about these problems and the data set as well, and what are the deliverables that are expected from the participants. Please go through the website and read them. And coming to the next, and please note that it is mandatory to use the Intel One API AI Analytic Toolkit and libraries for the solution. So leverage the libraries and optimization for the maximum efficiency and better models. Coming to the next problem, so this is an open innovation theme. So this problem is focused on the challenges that many communities face in accessing the quality healthcare services. So as you know, like healthcare is a basic human right, and many people are unable to access it due to the various factors such as financial barriers, geographic location, language barriers, and limited healthcare resources. So this is an open innovation theme. Your task is to, you can work individually or you can build a team to develop innovative software solution that can help to improve access to the healthcare for um, underserved communities. And I have provided the link here. You can go follow the link and get the more details about these problems, and also mm, the data set that is required for these problems. And please, again I'm repeating, please note that using Intel OneAPI AI Analytic Toolkit is mandatory for these problems. And so let this is a reference point for all you for all the participants here. So Intel has AI reference kit, so it has collaborated with the Essentia to launch a series of trained AI reference kit for the open source community to increase the adoption of AI across industry. So each of these kit has used the optimized Intel AI tools that is powered by WebAPI, specifically Intel AI Analytic Toolkit and Intel distribution of OpenVINO Toolkit. So this kit include a solution brief, an overview of the value proposition describing the problem, solution, and impact. So this kit is an end-to-end solution for a use case of real-world problems. So this is a reference point for all the participants, so you can explore any one of the kit and you can see like how you can utilize the different optimized libraries like TensorFlow, PyTorch in your application to come up with the solution. And again in this kit there is a developer guide which include recommendation for framework, algorithm, data processing techniques, hyper tuning, quantization, every detail. And if you go to the kit, there is a link for the code repository. So each of this kit has GitHub repo which include the code snippet, configuration, dataset, and libraries before and after optimization. And it has also the benchmark result as well. Let let me uh, go through the website so that you guys can um, so this is the link that I'm talking about. You guys can use this as a reference point for the problems that is mentioned in the uh, hackathon. So if you open one of the kit here, so you can open any one of the kit here. Suppose I'm opening this disease prediction using NLP. So when you open this kit, so it has all the information like the what is the problem statement and what is included in this kit, and even all the data set and model, and what are the libraries that are being used in this kit, like Intel optimization for PyTorch and Intel neural compressor is being used here. And once you will click on the uh, download kit option, it will let you guys to the GitHub repo for this particular reference kit. So you can clone this library and implement it at your end, and you can understand how you can use the optimized libraries from Intel in your application. So this is a good reference for you. So please, so we have already provided the link for this um, reference kit, so please go and explore it. So there are other reference kit as well for different domains, like for the financial services, for the consumer product, and other. So please explore at it at your end. And so coming to this slide. So yeah, so these are the deliverables that is expected from the participants during the first phase and the second phase. So first phase has already been opened and it will closes on 29th March. So we expect from the participants that uh, they share a presentation that will contain a description of what you have tried to build and what problem you are solving, and it should clearly mention that users of Intel OneAPI toolkit and libraries, and SQL and DPC++ libraries as well. And also the participants are required to submit comprehensive write-up details and their chosen theme and the approach to the problem that they are trying to solve, and the code used to build their solution. And this write-up should be in the format of a technical article posted on Medium, and this write-up will be evaluated by the judges for the functionality and creativity of the submitted solution. Therefore, it is a crucial to submit a complete and clear write-up to increase your chance of winning the competition. And then we expect a readme file which will contain the clear step-by-step instruction on how to build, deploy, and uses of the application. And we also expect a video showing the demo functionalities of the web application over the YouTube and Drive, if it is application for your problem statement. So this is what we are expecting from the first phase, which is the ideation phase, and the second phase, which is the prototype phase, that will go live from 6th of April and it will closes on 6th of May. So we are expecting a code file for producing the so we are expecting source code file for producing the solution file, and then we also expecting the output file that will contain the predicted readmissions. And you need to share a project on GitHub with source code, so we are expecting only the skeleton of your code. And now we are expecting the video showing the demo functionality of the web application over the YouTube and Drive, and a presentation is required that contain a description of what you have tried to build, what problems you are solving, and why your application solution should be considered for the final round. So again, it is mandatory to use the OneAPI AI analytic toolkit and libraries such as SQL, DPC++ libraries from Intel. So this is what expected. And so if you have any queries or doubt regarding this hackathon or the anything, please post it on the Discord channel. We will reach out to you. And these are the rules and guidelines for the hackathon. So the final submission, so please remember that the final submission should be made via devmeshintel.com. So and the code should be also available on the GitHub. So you will have the GitHub repo for your application and you will submit on the devmeshintel.com. And again, the participant must use Intel OneAPI toolkit and libraries such as SQL, DPC++ libraries to participate. And participants are expected to write up about the theme they have chosen, as I have mentioned in the previous slide, uh, for the judges to evaluate. And there are other hackathon general rules, like this online hackathon, participants can only participate from India, Australia, Indonesia, Japan, Malaysia, New Zealand, the Philippines, Singapore, South Korea, Sri Lanka, Thailand, and Vietnam. And this is a team hackathon. The participants' team should consist of no more than 5 members, including the team leader. So if you want to read more on these rules and guidelines, please follow the link here and you will get all the details regarding the rules, problem statement and everything. So I encourage all the participants to please do participate and come with the your innovative solution for the problem statement that I have discussed. And there are pretty exciting prizes as well for the hackathon for the winners. So please do participate and share your results with us. So this ends the today's workshop. So if you have any queries, we can discuss now. So if you guys have any queries or doubt regarding the workshop or hackathon, please feel free to post it in the chat or in the uh, Discord channel. And also, you guys will be getting a survey form. So please provide your feedbacks through the survey forms so that we can improve in our next sessions and workshops. So please provide your feedbacks. Hackathon link. So we have already provided the hackathon links here. Yeah, so you can see that in the chat survey link has been also shared. Please go and submit. So which environment setup file was run before running Jupyter Notebook? So this link we have already shared with you. It is a GitHub link uh, named as Intel OneAPI Code Maven. So you can clone this repo and run the Conda environment Python notebook for the environment setting for the second demo. For that is based on the TensorFlow stock TensorFlow framework.
Present, I would like to call out a question.
Yeah, sure, Kavita.
How is OneMKL different from Julia? They look similar with respect to the functions and use cases.
OneMKL. Can you repeat the second one? OneMKL with?
How is OneMKL different from Julia? Guess they look similar with respect to the functions and use cases. This is from Abhay Sapri.
Okay, so OneMKL is a part of OneAPI based toolkit, as I have earlier mentioned. So, which is a cross architecture and a multi-vendor tool. So, you don't need to like if maybe function will be same, but you don't need extra program settings or extra changes that you are required to run the code on CPU or different architecture like CPU, GPU, or AI accelerator. So you can run the single code on different architecture like CPU or a GPU. So this is the main specialty for the OneAPI libraries here. So they are highly optimized and it can be implemented on various architecture. So almost all. Yes, Vishnu.
Just wanted to bring another question. So you have explained a lot of things, right? So we started from 1DNN,
Yeah.
and you showed the integration of 1DNN with TensorFlow and moved on to 1MKL. So we are talking about a lot of libraries. So for the people who are participating in the hackathon, right? So if they use TensorFlow, do they have to be conscious about 1DNN or 1MKL, or will they get all the benefits without doing anything specific about it?
Yes, Vishnu. So, as from the start, I'm focusing on this part. Like, if you are using the AI analytic toolkit, so if you are using the Intel distribution of TensorFlow or IPEX from AI analytic toolkit, 1DNN and or 1MKL is already integrated with these libraries. So you don't need to download or install it at your end and try these libraries at your. This has been already integrated with these frameworks. So if you are using the framework, you are already enjoying the benefits from 1DNN and 1MK libraries.
Great, thanks. That answers. Just a follow-up question. So if I'm participating in the hackathon and the use case that I'm tackling uses PyTorch as the framework, so what should be the steps that I do to explore what Intel optimizations are available for, say, PyTorch?
So suppose you are using the Intel extension for PyTorch from AI Analytic Toolkit. So first of all, you can get started with the OneAPI samples that is already there for the PyTorch as well. Like how you can use it IPEX for the training and for the inference. And so if you want, let me go through the samples here. If you are using for the OneAPI for the PyTorch and TensorFlow, So so this is the OneAPI sample. So this is the AI Analytic Toolkit, and you can find here all the samples regarding the whether you want the samples for the Intel extension for PyTorch or TensorFlow or scikit-learn. All these for all these toolkits, the samples are here, getting started samples. So you can go and get started with. For example, if you want to start with the PyTorch, then you can open this folder and then uh, open this notebook to get started. And apart from this, you can also follow the IPEX documentation page, which is there. If you go a little for the IPEX documentation page, there is IPEX documentation page which include different examples from where you can learn like how you can use the Intel extension for PyTorch. So this is the IPEX documentation page. And if you go in the example section, there are different example like how you can use this function. So for IPEX, there is a function named as ipex.optimize. So this will apply optimization against your model. And so this is you are doing it for the training. So you can use here, you can see we are uh, giving the model and the optimizer for the ipex.optimize function. And similarly, you can select the data type as well. And for the training section, no, for the inference part, so you are giving only the model here for the optimization, and in the training you are also giving the model as well as the optimizer. So this is how you can learn about these libraries. There are documentation page for each of these libraries and different set of examples, and there is a API documentation as well if you want to go into more details about the APIs like ipex.optimize and other like ipex.verbs, all these documentation. And as I mentioned previously, so the good starting point will be to use this AI reference kit from Intel. So this reference kit is end-to-end solution for different use cases from real world. So you can explore this AI reference kit at your end to have an understanding like how you can use different optimized libraries from AI Analytic Toolkit in your application. So this is how you can get started with these optimized libraries and include it in your application.
Thanks, Asu. That explains.
Yeah. So if you have any queries, any queries after the workshop, so you can always reach out to us with our Discord channel and post your queries. Our expert will answer your queries. And so we are at towards the end of the session now. Thank you all. Over to you, Sukriti.
Thanks, Vasudha, and thank you everyone for joining us. I think we had an amazing session in